Some characteristics you need to be aware of. First, the formula for work is force times distance. W equals F times D. The unit for work is the joule. The object must move if you are doing work. Otherwise, it's not work. And the force and direction for work have to be going the same way. Emily.
I lost my pencil.
Well, let's make it quick. Who can give me an example for work? Your job was to come up with one example and one non-example for work for each word. Who can give me an example for work? No? All right, here's mine. If you don't have your own, you have to write both of mine. Lifting your backpack off the ground is an example of doing work. Closing the car door is another example of doing work. Derek, are you writing? Some non-examples. Just holding your backpack on your back, no matter how heavy it is, you can have 18 bricks in there. And you might have to hold it all day long. That's still not considered doing work in the science world. Or pushing against a wall that doesn't move is not work. I could send Trevor up to the board, and I could make him stand there for the rest of the day, pushing as hard as he can on the blackboard. But if the blackboard doesn't move, then Trevor is not doing any work. Okay, anyone from this table, when you're done writing, may go sign up for an activity. Bless you. Okay, moving on to our next word. The next word is mass. This is a review. Gavin Schaefer, what's the definition of mass?
A measure of how much matter an object has.
Good. If anyone doesn't get everything we write down, this will be available on Blackboard. You can go back and fill in what you miss. Some characteristics of mass. The unit for mass is kilograms, abbreviated kg. And I put this characteristic that mass does not change in space up here for a reason. When you are done writing, anybody from this table can go sign up for an activity. The reason I put that mass doesn't change in space is because your mass is not dependent on what? Gravity. Something else about you is dependent on gravity, but mass is not. Does that mean your mass never changes? Does that mean your mass never changes? Are you the same mass now as you were when you were 2? No. Are you more mass now or less mass now? More. Are you the same mass now as when you're 45? No. Most likely when you're 45, you will all have more mass. Okay, some examples of mass include solids, liquids, gases. Anything in those categories has mass. There is air in my room. That air has mass. You can measure it. If you put a glass with some saran wrap over the top of it on a triple beam balance and measured it, you'd be measuring the mass of the glass plus the mass of the air. Then if you take a straw and suck all the air out and close it up real fast, Would the glass have more or less mass? Less, because you took the air out. Things that do not have mass. Energy. Energy does not have mass. Okay, our next term, weight also does not have mass, or is not mass. Weight and mass are often confused as the same thing. It's important to know your non-examples as much as to know your examples. Okay, our next word. Dawson, what's our next word? Force. The definition for force is?
A push or pull that changes motion or shape of object.
Good. Some characteristics for forces. The formula says F equals m times a. We know these already. This is a review. The unit for force is newtons. When you apply force, the objects may or may not move. They don't have to move. Like I said, I can send Trevor up to the board and have him push on the board all day long. But if the board doesn't move, that doesn't mean he's not applying a force. We know that force affects acceleration. Newton's second law tells us that if you have more mass, you need more force. And here are some examples of forces we've learned about. Balanced forces. Unbalanced forces. Which one of those makes an object move? Kara? Good job. Gravity is a force. Friction is a force. What are the forces named in Newton's third law? I'll give you a hint. It's two of them. Action and reaction. Good. Kim, do you have those? Tyler, you got them? Some non-examples for force. Mass is not a force. And I also put space as an outer space because it does not have the forces we know as gravity or friction. Our next term is weight. This is another review word. Megan, what's weight?
The force of gravity.
Some characteristics for weight. The unit for weight can either be in newtons or kilograms, depending on what you're measuring, why you're measuring it. This table can sign up for an activity when you're done writing. Weight relates to gravity, whereas mass did not, which is why your weight will change in space or if you were on another planet. An example of weight might be a 10-pound bowling ball. Would a 10-Newton bowling ball feel the same? Is a pound the same as a newton? No, 10 newtons would be way less than 10 pounds. Some non-examples. Mass. Always confused for weight. Time to get those two things straight. Our next term is Newton. You had to look for this one in the index. Unit. The unit for force is the definition of Newton. The unit for force. How many of you found this? Okay, good. Some characteristics of a Newton. A Newton is equal to a kilogram times a meter per second squared. A kilogram times a meter per second squared. Some examples of Newtons. I put friction. Why is friction an example of Newton? Gavin?
Because friction is a force.
Right, because friction is a force, and you use newtons to measure force. Non-example for Newton is a kilogram. It's part of a Newton, but it's not just kilograms. Kilograms is the unit for mass. Good. A joule is also not a Newton. Another non-example is the joule. You guys can go sign up whenever you're ready. Our next term is joule. This is a new one for you. This is a new unit. The joule is the unit for work and energy. Some characteristics of joule. A joule is equal to a newton times a meter. If you apply 1 newton of force and you push the object 1 meter or pull the object 1 meter, you've used 1 joule of energy or you've done 1 joule of work. It's abbreviated capital J. Why do we use capital letters sometimes? Keaton?
It could mean other things.
It could mean other things. In this case, that's not the reason. Why is Newton capitalized? Good job, Emmett. It's named after a person. This is named after a person also. An example of joule might be you gave an object 25 joules of potential energy. Or you did 25 joules of work. Non-examples for joule, Newton, and kilogram. Energy. What is energy? Brendan. Very good. In order to do work, you have to use energy. The unit for energy is joules. There are many kinds of energy. We're going to learn about 5 of them, some more than others. Energy can be transferred. What does transferred mean? if I transfer money to you, Morgan, what does that mean? Right. Energy can be given to something else. Energy can also be changed by doing work. Some forms of energy are mechanical, nuclear, electromagnetic, thermal, and chemical. The non-examples for energy are solids, liquids, and gases. Why might I have made those my non-examples?
They have mass.
Right, because they have mass. Can a solid, a liquid, or a gas have energy, Elizabeth?
No.
Yes, it can have energy, but it is not energy. It's not the same as energy. It can use energy and have energy, but it's not the same as just saying it is energy. Let's look at a specific type of energy now, potential energy. Who found our definition for potential energy? Sabrina? Good. And I shortened that up a little bit to say due to its position or condition. The unit for potential energy, just like every other energy, is joule. The formula is EP, that means energy, potential, equals M times G times H, MGH. Potential energy can change to kinetic energy if you do work. It can change to kinetic through work. And a factoid you need to know in order to calculate potential energy is that gravity equals 9.8 meters per second squared. Just write that in this box. You'll come back to it later. Gravity equals 9.8 meters per second squared. Okay, I'm giving you two examples. One for gravitational potential energy. The example is a drop of water about to drip off the faucet. It's just hanging there, ready to drip. That has gravitational potential energy. The other example is elastic potential energy. A stretched rubber band has elastic potential energy. Can you move something when you stretch a rubber band like that? Can you make something else move? Sure. If you stretch a bowstring back, you can make an arrow move, right? If you stretch a slingshot back, you can make a rock move. If you stretch a rubber band back, you can make your cat move. Right? Gabe?
Or if you stretch a bungee cord, it makes you move.
Very good. If you stretch a bungee cord when you jump off of a bridge or someplace else, it makes you move. Some non-examples for potential energy include a person running or a leaf falling. Sorry, there you go. Why are these non-examples? Think about the difference between the examples and the non-examples. What's the difference? Megan?
Like the first one is about, it's about stuff, but then it's like, those are, because I think it has like it's almost energy, like the rubber band, like you're just stretching it, like you're not throwing it.
Right.
Like, so maybe.
So the difference is
It's just, yeah,
one is moving, the other is not. Right? Okay. Next word is kinetic energy. This is the energy of motion. Your characteristics include the unit, the formula. The unit is joules. The formula says 1/2 mv squared. 1/2 times mass times velocity squared. 1/2 mv squared.
Is it just
EK. Kinetic energy can change to potential energy through work, just like potential can change to kinetic. Some examples of kinetic energy include a ball in motion, if it's rolling, or flying through the air, or a leaf falling. Or walking down the road. If you are in motion, if you are moving, you have kinetic energy. Non-examples include a stretched rubber band. It's not moving. Or a drop of water right before it drips. Our next term, our last term, is mechanical energy. Go ahead, Derek.
The number of times a machine multiplies the force.
No, you gave me mechanical advantage. There's two mechanicals in the glossary. Here's your real definition up here. The combination of the kinetic plus potential energy an object has. The combination of kinetic plus potential. Characteristics include the units. We should know by now the unit for any energy is joules. The formula says that mechanical energy equals EK plus EP, which means kinetic plus potential. So this is an easy formula, you just add them up. We say that mechanical energy is conserved. What's conserved mean? If you conserve water, what does that mean? Gabe?
Saving.
Yeah, to save it. Mechanical energy is conserved by changing from kinetic to potential. This kind of energy can be turned into thermal energy through friction. Because of friction, mechanical energy turns into thermal energy. Examples: kinetic plus potential, a leaf going downstream, or a roller coaster. Roller coaster is a good example because you get a lot of potential and a lot of kinetic energy in that. Another example of something with mechanical energy is a pencil sharpener. Some non-examples: light and heat. These are different forms of energy, not mechanical. When you are finished,